In the heart of the cosmic night, when telescopes turn toward the depths of the sky, it is not light that tells us the most enigmatic story of the universe. It is shadow. It is the void that bends space. It is what cannot be seen, yet holds everything else together. For decades, astronomers have been chasing a silent presence, a substance that does not shine, does not emit radiation, and yet dominates the very structure of the cosmos. We call it dark matter. Not because it is black, but because it is invisible. And today, thanks to the most sophisticated eyes humanity has ever built, we are beginning to suspect that the mystery might be even deeper than we once imagined. Until only a few years ago, our understanding of the universe rested on elegant models, confirmed by increasingly precise observations. Galaxies rotated too quickly compared to their visible mass. The seemingly inevitable explanation was the existence of some hidden, additional mass. Gravitational lenses, distortions of spacetime predicted by general relativity, revealed concentrations of gravity where there was no light. Everywhere we looked, the message was the same: something escapes our instruments. According to current estimates, this invisible matter represents about 85% of the total matter in the universe. And yet, we do not know what it is. The James Webb Space Telescope, launched in 2021, was designed to see what the human eye cannot even imagine: infrared light that has been traveling for billions of years. Thanks to this ability, scientists have been able to observe the oldest galaxies ever detected, born within the first 400 million years after the Big Bang. And right there, in those faint primordial glimmers, something doesn't add up. The galaxies observed by Webb appear too large, too bright, and too well structured compared to what cosmological models based on cold dark matter predict. In theory, the formation of cosmic structures, stars, galaxies, clusters, should have been slower. Dark matter was supposed to act as a gravitational scaffold, slowly pulling visible matter together and allowing it to clump. But the data reveals something different: mature structures in a universe still in its infancy. What does all this mean? Were we wrong about the nature of dark matter? Or do our cosmological models need to be rewritten from scratch? One of the most fascinating hypotheses is that dark matter is not completely cold, that is, static and slow, as long believed. It may have a warm, or even hot, component, capable of moving faster and influencing the formation of early galaxies in a different way. Others suggest that dark matter may interact with itself or with unknown forces, an interaction that would modify its distribution and gravitational effects. And what if the problem isn't dark matter, but gravity itself? Some theoretical physicists, not without controversy, propose that the law of universal gravitation, as well as general relativity, might need corrections on cosmic scales. A bold idea, certainly, but one that reminds us that every great scientific revolution began with data that didn't fit the theory. With its extraordinary ability to look back in time, the James Webb Telescope is mapping an ever more intricate picture of the primordial universe. And every new image, every spectrum of captured light, seems to add more questions than answers. For example, some of the observed galaxies appear to be surrounded by halos of matter that cannot be explained solely by visible mass. Is that the sign of dark matter? Or of a new kind of particle? Perhaps something we have not yet imagined? Meanwhile, particle physicists are searching in vain for dark matter in underground laboratories, using ultra-sensitive detectors and beams of accelerated particles. Yet so far, nothing has been found. It's as though the universe refuses to reveal this secret, leaving us only fragments of a hidden truth. And in those fragments, in those anomalies, might lie the next great revolution in cosmology. In the silence of the primordial universe, among the newborn galaxies and the light that has yet to cross the vastness between the stars, perhaps lies the key to deciphering the essence of dark matter. But the closer we get to this elusive truth, the more we realize that what we're seeking might not be what we thought at all. Some scientists have begun to speak openly of new physics, hypothesizing the existence of particles not included in the Standard Model, the theory that has explained the behavior of fundamental particles for decades. Among the most intriguing hypotheses are the so-called axions, ultralight particles predicted by certain symmetry theories, which could form an invisible sea permeating the entire cosmos. Others point to WIMPs, weakly interacting massive particles, massive objects that interact only through gravity and perhaps weakly with other forces. Yet despite decades of experiments and billions of euros invested, there is still no direct trace of these elusive entities. Meanwhile, new observations gathered by Webb are pointing in another direction. The distribution of dark matter is not as uniform as once believed. In some ancient galaxies, strongly asymmetric, almost chaotic gravitational halos have been observed, patterns incompatible with the calm, stable gravity expected. It's as if, in those regions, dark matter behaves more dynamically, or is influenced by unknown phenomena. Even galaxy clusters, enormous structures composed of hundreds of billions of stars, are offering surprising clues. Some seem to display interactions between dark matter halos, as if these halos could collide, merge, or react to each other. A behavior unthinkable if dark matter were entirely passive and non-interacting. But there is more. Webb has revealed the existence of galaxies without dark matter. A true conceptual challenge. How can a galaxy exist that shows no signs of the invisible gravitational influence that governs the motion of stars? These objects, rare but real, are shaking the foundations of our theories, opening radically new scenarios. Perhaps dark matter is not a substance evenly spread everywhere, but something more complex, something with its own dynamics, internal structure, or even multiple species of invisible matter. And as the data accumulate, so does the tension. Every new observation, every spectrum of collected light, every measured gravitational distortion is another piece of a puzzle whose final image we still cannot see. Dark matter might be the reflection of extra dimensions, as suggested by some versions of string theory. It might be the remnant of primordial cosmic phases, like a Bose-Einstein condensate on a universal scale. Or, bolder still, we might have misunderstood the very essence of time and space. Yes, for some theoretical physicists now advance daring speculations. That dark matter is not a thing, but an emergent effect of the universe itself. A quantum residue. A shadow left by the topology of space-time, an intrinsic curvature that does not depend on the presence of mass, but on the deep structure of the quantum vacuum. An echo of broken symmetries at the dawn of time. And here, mystery merges with cosmic poetry. For to seek dark matter is, in the end, to seek ourselves, in a universe that challenges us to look beyond the surface of things. It is our desire to understand what cannot be seen, to listen to what makes no sound, to measure what evades every instrument. It is the arrogance and the wonder of a species that, from a small planet on the edge of an ordinary galaxy, dares to question the invisible. Dark matter, perhaps, is not merely a component of the universe. It is a test. A challenge to our intelligence, to our imagination, to our ability to embrace the unknown. The James Webb Telescope has opened a window onto a cosmos deeper, older, and more mysterious than we ever dared to imagine. And every new image is a question. How much do we still not see? Perhaps the real dark matter is not out there at all. It lies within the folds of our understanding, in the shadowed regions of human thought. An invitation never to stop, to push beyond the limits of knowledge. Because the darkness we explore in the universe is the same one we carry within, vast, silent, full of possibility. If you've made it this far, it means you love curiosity as much as we do. If this journey has inspired you, leave a like, write a comment, and subscribe to the channel. It's the best way to support what we do. Your presence truly makes a difference. Until the next exploration.